Yes. All right, everybody. Karl Hughes.
Okay. That doesn't cut into my time, right? I only have 10 minutes, so I really got.
Oh, you got 3 minutes.
Oh. Okay. So back in 2007, before I got into software engineering and startups, I worked at GE Appliances in Louisville, Kentucky. Anybody from Louisville? No. That's too bad. I was afraid of that. I worked in washing machines. So washing machines are pretty complicated these days. There's a lot of parts to them. And I was working on a new part called a smart dispense pedestal. Did anybody grow up with one of these? I'd be super surprised. I think GE did it for like 5 years, and then they discontinued it. So the smart dispense pedestal would allow the people who buy their detergent all in bulk at Costco to pour a whole month's worth of detergent into the base of the machine, into the pedestal, and then every time you ran a load of laundry, it would automatically dispense however many milliliters of detergent you need for that load. So for those of you who don't want to open that drawer every single time, I know, it's pretty rough, this was here for you. Now, I learned a lot of things as an intern. First of all, end-to-end testing on washing machines is easily as boring as it sounds. We literally were handed a clipboard from the senior engineers, software engineers. They would say, okay, go flash 100 washing machines down in the test bed, down in the basement, and you guys all night will be like pressing every combination of buttons trying to break it. And that was how they do end-to-end testing on washing machines. I don't know if they still do that, but it'd be interesting to know. I learned that there's a strange subset of the market that I don't fully understand who will pay $1,500 to pour their detergent once a month instead of every single time they do a load of laundry. I learned the city is pronounced Louisville. So since nobody's from Louisville, could you say it with me? It's not Louisville, not Louisville, Louisville. All right, you're all ready. Awesome. And then lastly, and what this talk is really about, I learned that inventions are not almost never as unique as they seem. I love this little meme on the internet. So let's break this down. GE was like super pumped about this smart dispense pedestal because nothing new happens in washing machines. Like they went front load, and that's the last big innovation in washing machines we've seen. And so they're first to market with this big, I don't know if from GE is watching this. No, they're first to market with this big thing, the smart dispense pedestal, super cool. People load their laundry once a month. But when you break it down, it's really not that complicated of an invention. So there's an electrical system, make sure the thing gets power, turns on and off, communicates with the main computer up in the top of the washing machine. There's the detergent containment system where you actually have your detergent, sort of stored so it doesn't flow all over the place, obviously. And then you've got peristaltic pumps. We'll get into what those are in just a second. But those actually pump the detergent into the back of the washing machine. So pretty simple at its core. And if we break those systems down even further, they're actually made of a lot of really rudimentary components that have been available for a long time. So back in the 1920s, as electricity started to get put into houses, the original wires that were built in houses were just unshielded, like straight pieces of copper. And as soon as things got wet, there's a fire, and the whole house burns down, which turns into a neighborhood fire, which turns into a city fire. So this was a huge problem in the early 1900s as electricity came around, and there's these big wars about how dangerous electricity was. Well, it turns out the solution is just put a piece of plastic or paper around that wire, and you save yourself like most of those house fires. So that got invented in the 20s, and so did harnesses, and we pretty much have done the same thing with wires ever since. So nothing super new there. In 1936, the first printed circuit boards came on the market. These are basically the main controller boards everywhere in appliances. Now, today, I think appliances are getting a lot smarter. I haven't worked in appliances for almost 10 years, so I don't know as much about them. But back then, this is all we were using. And then the last invention in the electrical system that's actually kind of interesting is a resistive level detector. And it's like a two-pronged thing that sits down inside of the detergent container. And as the level goes down, the resistance goes up when you apply current across the two prongs. So you can tell the user, hey, you're about to have to go back to Costco, buy a whole new load of detergent. The detergent containment system is next. So before the invention of HDPE, which is high-density polyurethane plastic, it was actually really hard to transport liquid detergent because this stuff is super caustic. This is something that I learned working at GE that I never would have guessed, but detergent will eat through your shoes, it'll eat through your clothes, it'll eat through your skin, so don't leave it anywhere. You have to use it and wash it right away. HDPE solves that problem by making them able to transport liquid detergent, and we would use that in those main tanks of the washing machine. And then the other primary component here is a child-proof lock. because, child-proof cat, because of course this thing's down at kid level. It's like right here. So you get kids opening this thing up and sticking their fingers in there and theoretically like, drinking detergent. So we got to prevent that, and that's important. And then the last piece, which I think is super interesting, is peristaltic pump. So aluminum was actually relatively late to refine for metal, so the sheet aluminum didn't start coming out until the 1820s because it's like a powdered form, so it's kind of hard to work with. And it's got a low whatever you call that, heating point, I don't know, melting point. But as aluminum, which is a lightweight but pretty strong metal, came on the market, they could build these things called peristaltic pumps, and this was invented in 1855. So a peristaltic pump works with a single motor, and it's got a rotor head that rotates, and then it's got 3 to 4 rollers, which actually compress and press a liquid through a hose. So what's really cool about this, in medical settings, you don't want the liquid to ever touch part of the motor because it introduces oxygen, it introduces other kind of like bad things, especially if you're doing like a blood transfusion. So this enabled blood transfusions in a way that was not really super possible before 1850. But it's also really helpful for moving detergent because detergent can't be exposed to any kind of outside things. It can't sit out in oxygen for very long, so it needs a closed system like this. You also need a very precise amount of laundry detergent with every load because if you've got a small load, you don't want to pump in a ton of detergent and vice versa. So this was important. And then the last invention required to get these peristaltic pumps to work with detergent was neoprene tubing. And typical hoses from these peristaltic pumps would get broken down really quickly by the detergents. And so they get torn down and you can't really use them for long. So this Viton neoprene tubing was the last bit that enabled the whole thing. So this whole system gets patented in 2007, right around the time I'm working at GE. But when you look at it, it's literally made of parts that you can buy at a hardware store today and in 2007. There's nothing super, super unique about this. And what was really, influential to me was realizing that there's really not that much of an invention here other than somebody got creative and packaged the thing nicely. And that's what a lot of these inventions from GE and a lot of companies end up being. I think Isaac Newton recognized this in the 1500s by saying that we can see further by standing on the shoulders of giants. The idea here is those of us in engineering are almost never inventing things whole cloth from nothing. We're starting at this huge leg up from where the people a generation before us did. So invention, and GE sort of like talks about this a lot, but this is how I've started to look at invention since then. It's basically just taking existing technologies and finding novel uses for them. The cool thing is we see this all the time in software, and this is starting to get, I think, more and more common in my career as a software developer. So obviously we're all using GitHub and NPM for everything because this is JavaScript land. So public package managers, like this is how we start every project, right? Anybody start a project without GitHub? I haven't seen a hand come up for that yet. But we've got even better tools coming down the line. So things like Zapier. Anybody using Zapier on a regular basis? Get into this. This takes like a ton of programming jobs out of the pipeline. Because what this does is hooks up hundreds of APIs and lets business people write logic that sort of does whatever they want with it. So you can have a message from Facebook come in and trigger an email. You can send that off to Trello or do whatever you need. There's a ton there. And then you've got tools like Webflow, even DraftBit. I thought I'd get Peter's attention over there. They allow you to build a front end with just a simple GUI. And then you've got tools like Bubble, which actually allow you to build whole web applications front and back end without writing any code. I've seen startups actually built up this thing that make tens of thousands of dollars a year. So yes, these are early prototypes, and yes, there's a lot of room for improvement with all these tools, but they're changing the way that we build software today. So what do we take away from this, and how do we stay in a job? As these tools get better, as we're able to cobble things together with lots of packages, there's a few things. First, we have to take it as our job to understand the true problem. So there's a technique called the 5 whys, which basically says you never take for granted the first reason that someone gives you for doing a project. You always ask why and get to the real root cause. A lot of times the problems that we're solving for are not technical or software problems, they're people problems and process problems. So the sooner you can recognize that, the more money you can save your company and the more valuable you'll be as an engineer. Second, you got to get out of the office, which y'all are doing. So welcome here to a conference, which is a great place to learn about the tools and cool things that are happening out in the world. But there's also events like your meetup groups, your user groups, your newsletters, whatever it is. Get out there, start meeting people, get out of your comfort zone. And then last, embrace the future and what's happening. So nobody writes their own email servers from scratch anymore. We all use SendGrid or Twilio or something like that. Nobody racks up a server in their closet anymore. Instead, we get to use AWS or Heroku to quickly and easily host things for cheaper than we ever did before. And very few of us write C code anymore. Is anybody writing C code? Yeah, I love it. There's always a couple. Good for you. Keep the dream alive. But for the rest of you, higher level languages like PHP, JavaScript, Python, Ruby, all this stuff, it's great, and it solves most of our problems. We don't need to go to that lower level C code or assembly code. So stop thinking to yourself, how do I write code to solve this? What do I need to build to solve this? And start asking yourself, what is the problem, and how can I really get to the root of it and figure out how to solve it? So thank you all so much for your time.